Jeff at East Performance. Doing something different for a Tech Tip Tuesday. This engine was one of the ones we ran in the dyno a couple weeks ago up at S&S. This is a 5.9 base engine put together for 2.6 smooth bore and work stock, diesel pulling classes mainly. It's got a beans, girdle, Apex billet rods, Molly Motorsport forged pistons, total seal, race ring pack. And we had an issue with this thing on the dyno. 26 pulls into it, we had a bunch of water come out of the stack pipe on the dyno, and still trying to figure out the cause of it. We figured it was a cracked head. We pressure tested the head. Head checked out okay so far. 45 minutes in hot water, no problem. So we're tearing down the short block here. We're gonna look for a cracked cylinder wall or a hole in the wall. And we're gonna take advantage of that. We're going to check the main bearings, rod bearings, look everything over. We're gonna compare our bearing clearances to before when we assembled it. So it'll be pretty cool. Again, it's a beans girdle, 12 millimeter, and it's Apex billet rods. So it'll be pretty cool, and we're gonna show you what we find. The good, the bad, the ugly, whatever it is, we're gonna show you. All right, so one of the first things we're getting into here, we're checking the girdle. The beans girdles, if you're not familiar with them, they have preload screws here down the center. That's one of the features I like about them. These preload screws or bolts go in, they thread into the girdle, and they press down into the top of the cap. And then you have a jam nut you tighten, and you're preloading the girdle to the top of the cap to help deflection in the center, to help the bearing fret, the cap shifting. So again, one of the features that I like about them, and I've always wondered, with this little bit of preload you put on them, do they actually do anything? The first time you start this, is that minimal preload you're putting on is that can be lost. So this is pretty cool. We're gonna go in, we're gonna crack the jam nut loose, and we're gonna put the torque wrench back on them and check them. Now the way Beans tells you, I believe they tell you 20 inch-pounds of torque on the preload screw, which if you know anything, that's not much. Basically that's a measurable amount. You're getting a measurable amount of preload, even, and then you tighten the jam nut. I'm not always satisfied with somebody else's instructions. To me, 20 inch-pounds on a coarse thread screw, you go tighten that jam nut, you're very likely gonna lose that 20 inch-pounds. So we took the time to go through on a couple engines. We torqued them to 20 inch-pounds, and we measured the main housing bore. Well, first we measured it, then we torqued it 20 inch-pounds, measured that main housing bore, didn't see any deflection, went to 25, went to 30, and we kept on going until we seen 1/10 of a thousandth of the change in the size of the main housing bore. So we knew that we loaded enough to change the main housing bore. So then we backed it off, then we went back tight again, then we torqued the jam nut and checked it again, and of course that 1/10 of a thousandth was then lost when you tighten the jam nut and pull that screw up tight into the threads in the girdle. So we played around with that until we can get the maximum amount of preload after torquing the jam nut, and did not change our main housing bore. So that's what we do. So now when I assemble, I torque my perimeter bolts, then I put factory oil pan bolts in because of the length of them, and I go around and torque them. Then I do my preload screws last, because my theory is when you pull the perimeter bolts or the factory, stifter plate bolts, and then the oil pan bolts, you're potentially pulling that girdle down like that, because you got an O-ring that you're crushing, and I put RTV as well. So you go and you crush that down, you could bow up or belly up that girdle in the center. So that's why I do that first, then I do my torque. Again, that's another step to help make sure that you're maintaining preload, because if you do that first, it may not, it may go away when you torque everything down. So the reason I mention that is to give you a tip, but also, if you notice, I pulled my oil pan bolts, obviously. I didn't feel like putting them back in, and I also zipped most of the perimeter bolts out before I thought of that. So this one here, both of these are still torqued. My factory girdle bolts, or as I call them, the perimeter bolts, they're still in there. So we'll be able to check that one, and I'm gonna check a couple other ones. We'll see if we notice a difference. So again, what we're looking for is I'm gonna hold the set screw, crack the jam nut loose, and I'm gonna put my dial inch-pound torque wrench right here on the preload screws and check them to see where it's at compared to where it was before. So that's the first thing we're doing in order to check the girdle. So it's very important that you hold that set screw, and because when you're talking 20, 30 inch-pounds, you ain't talking much. So I'm gonna hold it. All right, did not move. Don't have to back the jam nut off much. All right, now that one did move on me a little bit. I felt it move a slight bit, so we'll still be able to see and tell where it's at. This one here. All right, that one did not move. So 2 out of 3 we know will be very accurate. So again, inch-pound dial torque wrench. Make sure it's set right. I'm gonna go to this one here. All right, that one was right at where I had it torqued to. I have my engine build paperwork from when we originally assembled this engine. I went back and looked. When I hit my torque, it just started to move. So that one dead on. And again, this one still has a perimeter bolt, so this one should be really accurate. This one here, I know moved on me a little bit, tightened, so I expect to be a little bit higher. Yeah, it's a couple inch-pounds higher than where we set it at. And then we'll go here in the middle. So that one was about 20 inch-pounds higher. And I would attribute that to probably some deflection in the cap or the girdle. So we'll see. So we'll note that one. That one was higher. I'm gonna go ahead and off camera check the rest of them, and I'll document that, and we'll see. And I'm gonna put some more thought into that. Not necessarily a bad thing unless that cap was deforming and pushing into it. So definitely something, we'll go in and check the housing bore again on all of them, and we'll compare it to where before, and that'll tell us for sure. So we'll get back to that one. So next thing I wanted to do on this phase here, we're gonna check the main stud torque. 125 foot-pounds on a 12mm ARP. We're set at 125. Moved a little bit. Moved up, I mean, very, very small amount. Yeah, so they are moving, which tells you there's some movement going on. I'll go through and check them all. So I would like to not see that. Whenever I assemble any engine with studs, I do 2 or 3 torque sequences up to my final torque, and then I go back over at least once. So these were torqued at 125 at least 2 times, probably 3 times on this engine when I put it together. So, you know, again, that wasn't much. Now I'm gonna go ahead and get my digital. I'll just grab it now. I'm gonna get my digital one, and I'll be right back over, and we're gonna see what are they moving at. What's it taking to move them, and how much do they move to get to 125. So. All right, we'll get this thing zeroed. All right, so set at 125. We did these 3. I'm gonna go ahead and jump back to here and see if we can get that on camera. And about 115 is where it really started moving. Let's get. All right, let's do this one here. So. Yeah, I'd say about 95 or 100 foot-pounds is when it starts moving. Let's check another one here. Yeah, now that one, it's hard to tell how much it's actually torquing, but let's see. Yeah, I think about 95, they all move a little bit. So I would definitely like to not see that. So again, I'm gonna rip this apart now. I'm gonna knock the pistons out. I'll come back on camera. We'll check out the rods, we'll check the pistons. We know we had water go through this engine as far as in the top end. It wasn't ran with water and oil, but obviously got it in the crankcase. You can tell by looking at this junk. But all the cylinders are just full of rust. We hosed them out with W40, we wiped them out with Scotch-Brite, W40, Scotch-Brite, get them as clean as we could so that we could try to salvage the rings as far as inspection. The rings are junk, but in order to be able to check them out and not to hurt the pistons when we knock them out. So I'll get the rods knocked out. We'll look at the bearings, we'll inspect them. We'll be on camera for that. And then I will retorque all of the rods and we'll check the big end. We'll also check the small end, make sure they're still true, see if there was any egging, if they were stretching. And then we will do the same thing with the main bearings. We'll actually measure the housing bore. We'll go back and recheck our clearances. So we'll share everything. Like I said in the preview video to this, good, bad, the ugly, don't matter. We'll share it. Okay, so we're back at it here. As soon as we got off camera, I was thinking about why I noticed a gain in torque on the preload screw. So, as I said in my video, the reason that I go in and I torque the perimeter bolts and the oil pan bolts first is because we're expecting that girdle to move a little bit, right? Well, that's obviously what it was doing. I went ahead and threw the 2 perimeter bolts in, torqued them to the spec that I assembled them to, checked it right where I was. So I'm gonna go ahead and check it again. But yeah, dead on where I set it when I built it. So that shows you how much difference there is. If you're using the beans girdle, if you go in and you torque your studs, and then you torque your preload bolts, then you put your perimeter bolts or oil pan bolts, you will definitely lose any preload you put on them. So not that that's a bad thing, but that's just giving you a tip. So once I put them in, torqued them right where we set it. So we're good to go. So to me, that's killer. Very minimal preload, and it's all still there, right where we set it. So that's a really good thing. Really happy to see that. Now, on the other side, we noticed that we were seeing our main studs move a little bit. We got off camera. Hey, I'm gonna put the old school angle meter on here, right? And I'm gonna go ahead and turn it. We're gonna see how much does it actually move. And we can equate that to how far backed off it was. So this is not the most accurate thing, even though it was used for decades. Not the most accurate thing. But we are on 0. We're gonna get our torque wrench zeroed, and we're gonna see if we can keep this accurate here. So, come on. Okay, we are on 0, and I'm gonna start pulling torque. It feels to me like it's moving. It looks like it's moved a couple degrees. Now there's, okay, 125, and that's 5 degrees. No, that's 10. 10 degrees, exactly. Now, that is not the most accurate way of checking. I was pulling the torque wrench pretty slow, but engine builder-wise, that was accurate to me. 10 degrees. So we can calculate by the thread pitch how much that was. But I'd say I was pretty accurate by when I was feeling it, washing earlier, about 95 foot-pounds that it was starting to move. So again, 10 degrees. I'm gonna get with ARP. I'm gonna talk to them about that, let them know. It's nothing against their fastener. That's not the problem here, but I'm just gonna let them know and see how much torque did we lose. And then just like we developed our own method of the preloads, I will now change my torque spec when I'm assembling with the beans girdle. And that's not knocking anybody, there's nothing wrong, but that's good information. So 10 degrees is how much we're able to torque to get back to 125. So we'll play around with that, we'll figure out. All right, wanted to show a tip here with the beans girdle. As I've talked about, they have these adjusting screws. So these adjusting screws are also handy for pulling the girdle off. So you get to go in and push down right in the center of the cap and pop the cap off the dowels. So handy tool, keeps you from either pulling the girdle up off the block and pulling the caps with it, banging around on your crankshaft journals, but also helps control the dowels. So one thing is you run it down, and I do them all nice and even, nice and slow, but you gotta look, and if it's pulling off uneven, you wanna get a little pry bar and just relieve the side that's tight and working back and forth. So this works great. A lot less issues and frustration since I started doing this, and it works really good. Another tip, while I'm talking about it, with the beans girdle, we put ARP lube down in the tops of the caps, down in the bore that the dowel goes in, and that helps with this too. So just want to share that tip. So So we've got the engine tore almost completely down. We lifted the crank out, and before we pulled the main bearings and cleaned them, I wanted to get a quick video showing the watery oil that was, pumped into the bearings from the oil galley. So this engine was ran with the water in the oil. It did not make a dyno pull, but it was ran, and it could have made the last pull. It could have had a little water getting in there. We don't know, but this does show when you have water droplets coming out of the galley. There's your suction, there's your main oil galley feed, and you have water droplets running out. So this engine was ran with water, and these bearings still look this good. All right, so we got the engine completely tore down now, and we've had the time to inspect the components. So the one thing we really wanted to check out, really scrutinize, was the rods. These are billet triple beams from Apex Diesel. We knew these were good rods, but being able to run them and then tear them back down and check them is always nice for any component. So, again, 26 dyno pulls from 1100 to 1500 horsepower. And we tore this thing down. We checked the big end and small end, checked the small end. A little bit of signs of wear, which is normal at that power level, but as far as out around, perfect. They did not stretch, they didn't egg, so that's very important. And then same on the big end. We were, as far as being concentric, they were within a couple tenths of a thousandth of an inch. So they're right where they were when we started. So no deformation, no walking of the caps. So killer, really happy setting the rods. As far as rod bearings, pretty much what you would expect to see at that power level. We're very happy with them. For the most part, they still got the coating. You can see where they were loaded, but no rod issue or bearing issues at all from rods or mains. Look at the back side as far as fretting. You can see where, right here, we still got a crosshatch showing where they was staying put in the rod. So very pleased. All of them look good. We even went as far as to send pictures of the bearings off to Clevite, to one of their engineers, just to make sure they were happy and they didn't see anything that we were missing. So this would be number 6, which is always the one that gets started for oil. And number 6 looks great. You can still see the line all the way across where we went in and measured bearing clearance beforehand. So virtually no wear. They see a little bit of loading where it got the coating there, but rod bearings look great. Main bearings look great. Same deal here. You can see where we went in and checked bearing clearance with the dial indicator. The thrust looks awesome, both sides. I think we gained 2 thousandths of in play from when we assembled it till afterwards. I'll have to go back and check the paperwork. But as far as mains go, go ahead and zoom in on these on the cap side. This is where what takes a pounding here. And these bearings look awesome. The only thing I did notice, and I honestly didn't know what it was, so I talked to the engineers at Clevite, a little bit of edge loading you see right here. And this is number 7 cap. So all the torque of the crankshaft is exerted on this rear bearing here. You got 6 cylinders firing in line. You're getting all the load here. So right here on number 7, and then a little bit on number 6, that might be considered edge loading, and then a little bit on the front. So what that is, the edge loading, that is the deformation of the crankshaft. So when you've got that much torque and that much power, the crank is twisting, and we're talking, a couple thousandths of an inch, but it's twisting and getting out around, and that's what causes that edge loading. The engineer at Clevite said that's pretty normal and expected at the power level. This is a factory crank. Come on over here and get this crank. This crank looks awesome. So it's been sitting around a little bit here in the room in between time to do these videos. And we didn't really clean it up. We just kind of sprayed it down. But this crank looks awesome. It looks like it just came from the crank grinder. I was very happy with the crankshaft. The bearings, you can tell a little bit of trash went through. We were on the dyno. We did several hot retorques. We probably went a little long on the braking oil. We only changed oil one time. So they picked up a little trash, which is normal, but the crank looks awesome. So very pleased with that. And then on the girdle, still trying to figure out why we lost some torque. We have another engine. Unfortunately, we get to tear down now with the same girdle, one of our pulling truck setups that had an issue. So we are gonna get that one tore down, and we'll see if that has the same issue where it backed off 10 degrees. That'll tell us if it was something with this engine or if it's something with this setup. So again, overall everything's very good. We did find the culprit of our water in the oil. Unfortunately, we cracked the cylinder wall on number 5, split it wide open all the way down. So probably just a thin spot on the cylinder. This was a 98,000 mile block, so wouldn't have expected that. All the other cylinders look okay. So what I wanted to do before this video but didn't have time, and I plan to do, we're gonna take our ultrasonic tester and we're gonna go through, we're gonna check on both sides of that crack all the way around that cylinder and check every cylinder and determine if that was a thin spot on that cylinder is what caused that. So we know if that spot was the weak link or if it was something else. But the piston that come out of that hole still looks great, still usable. I mean, there's a little bit of, I don't know if I even call that metal transfer there, just scuffing in the coating. You know, right here, I'd say this is probably the side of the crack. So the piston's still usable, all the pistons were. Very happy, you know, overall with the pistons. Rings, it's hard to determine because they got so much water in them. But this engine was running great and overall good on blow by. It had a lot of piston to wall clearance. So you would expect, you know, some, you know, blow by because it had so much piston to wall. We set this engine up to where it could be ran wet or dry block, so to be expected. As far as camshaft, tickle pink with the cam. This is, you know, the Joe Gibbs driven oil for break-in, and then we switched over to some Pico like we always run. This is a used camshaft, and this thing looks great. I mean, every lobe looks perfect. The bearing journals look good. The cam bearings look good. So very happy with that. We did put, we line board this block and put 7 cam bearings in it. So the whole cam tunnel had bearings all the way through, but this thing looks great. Tappets look awesome, and the cam lobes look great. So again, besides the cracked cylinder wall, you know, this engine, everything looked great. We were pleased with the performance. So we wouldn't have got this opportunity to tear it down, maybe, if it wasn't for that cracked cylinder wall. I'd like to think I would have torn it down, but realistically we're busy, so we probably wouldn't have. So, you know, so now we're gonna go through and we're gonna sleeve every hole. We're just gonna sleeve all 6, put some good ductile iron flange sleeves in, and get this thing back in action. So do some further testing with it. So again, Apex rods, we're real happy with them. You know, we see people talk about bearing fret a lot. You know, 0 bearing fret on rod bearings, mains. So very happy with the Apex rods, beans girdle. It's a really good setup for 2.6 boot bore work stock, or obviously the street truck. You know, not many people are making close to 1,500 horse on the street. So happy with both of them. So thanks for watching.